next question. So in this question it is given that two networks are given like this. So between these two networks there are three resistors are placed. So okay, in this it is the arrangement given like this. So it is a 15 ohm and 5 ohm and 1 ohm resistor. The drops across this 5 ohm resistor is 10 volts and the drop across this 1 ohm resistor is 5 volts. Okay, and he asked to find the voltage across the 15 ohm resistor. Find the voltage across the 15 ohm resistor. So how can we solve this question? So this is the question given. These are the two networks. It is one network and one network. Two networks are given. Okay. So in these two networks, in between two networks, these are the three resistors are given. Okay. So according to the KCL, what is the KCL? Suppose if we take any node, n, okay, the algebraic sum of the currents is equals to 0. That means currents entering is equals to the current leaving. The currents entering is equals to current leaving. So from this what? Suppose if you take any node or any network, so what happens? The algebraic sum of the currents must be equals to 0. That means I1 plus I2 plus I3, okay, minus I4 is equals to 0. Right? See all the currents, entering currents. So according to our notation, you can take this one as what? Minus I1, minus I2, minus I3 plus I4 is equals to 0. You can also take like this. Okay? The algebraic sum of the currents is equals to 0. So because all are the entering currents, so that's why I have taken minus. You can also take plus, leaving current as minus, or you can also take entering current as minus or leaving current as plus. So from this what I can write? So I1 plus I2 plus I3 is equals to I4. Okay. So if it is any network or any node, so from this what we can say? So the entering current into the node is equal to the leaving current. Okay. The entering current into the node must be equals to the leaving current, or the entering current into the network must be equal to the leaving current. That means suppose if any network is there like this, okay, suppose if any network is there, okay, the entering current, let us suppose I, and it has to enter the network and the same amount of current will be leave the network. Okay, so the current will enter the network and the same amount of current will leave the network. So this is the principle according to the KCL, right? If this is what we have to write, so the entering current is equals to leaving current. Entering current is equals to leaving current. Okay. So if it is known, now come to this. How can we find the voltage across this? So how can we find the voltage across this? So it is one network. We have to find the voltage across the 15 ohm resistor. To find the voltage across the 15 ohm resistor, we should know the current across this. So how can we find the current across this? Okay, how can we find the current across this? See, if you observe this, across the 5 ohm resistor, there is a 10 volts voltage drop. Now what will be the current in this? Current will be equals to voltage divided by resistance. It is 2 amperes. Right? If you observe this, across the 1 ohm resistor, 5 volts drop is there. So what will be the current? Current will be voltage divided by resistance. It is 5 amperes. Right? So it is 2 amperes and 5 amperes entering this network N2. So what is the meaning of this? So the same amount. So the total amount of current is what? That is entering the network. So it is 5 plus 2, 7 amperes is entering this network. Okay. So only there are 3 branches. There is no other branch connected here. So through this branch, so this 7 amperes current must leave. So that's why 7 amperes must come into this. Okay, whatever the current is entering must also leave the network. Right or not? So that is the point you have to understand. Okay, suppose if one more branch is given like this, let us suppose this is I1. Now what will be this? This current must be equal to I plus I1. Like that. Suppose if 10 entering currents are there, let us suppose one more current is given like this. Let us suppose I2. So what it will be? It will be how much? It will be plus I2. Right? The entering current must be equal to leaving current. So that's why it is 7 amperes. Now, if it is 7 amperes, see, always you have to remember, always you have to put plus sign here, minus sign here. The terminal at which the current enters the resistor, that is the positive terminal, because always the resistor is a absorbing element. So that's why the current at which the point at which the current enters the resistor is the positive terminal. This is the negative terminal. So what about this? It will be equal to the voltage across this one is equal to how much it is? It will be 15 into 7. 15 into 7 means it is 105. 105. But how we are calculating the voltage? We are calculating the voltage by considering this side is plus, this side is minus. This side is plus, this side is minus. Now what is the voltage across this? It is minus 15 volts. Observe this. We are calculating the voltage across the 15 ohm resistor. Right? It is minus 105 ohms. 15 into 7 it is 105. Right? So this is the thing you have to understand. Why I have taken plus here? Why I have taken plus here? The terminal at which the current enters the resistor must be considered as a positive terminal. Then only it is following the principle. What is that? The resistor should absorb the power. So whenever the current enters the positive terminal of an element, that element can be said as it is an absorbing element. Right? So that's why this is the thing you have to understand. Okay? So the answer is minus 105 volts. Okay? So this is the thing you should know. So you don't think about this network. You don't think about this network. Whatever is there inside, it may be a node or a network. Don't think about this network. You forget about the network. So when he is asking about the current coming out of the current or going into the current, so you should focus only on the current. No need to think about what are the elements inside the network. Okay, no matter what are the elements are inside, don't bother about that. When he is asking about the current, you should only focus on the entering current. We should only focus on the leaving current. That is the thing you have to understand. Understand? Okay. Very conceptual question. If you observe this, so find the voltage V in this given network. Find the voltage V in the given network. So options are given: 9 volts, 5 volts, 1 volt, and none of the above is given. So how can you approach this? So what he has given, one network is given, and we have to find the voltage across this network, the terminals of this network, and the network is extended by these extra elements. So there is one current source, 2 ohm resistor and 5 ohm resistor is there. So how can we find the voltage? How can we find the voltage? To find this voltage, observe this. Can we apply a KVL here? Can we apply a KVL? So how can we apply KVL? So now I am considering like this, right? So if I consider like this, what it will be? 0 plus V. Okay. So 0 plus V minus, what is the voltage across this? What is the voltage across this? It is the voltage across this is unknown. The voltage across the source is unknown. Okay. Minus 2 into 2 amperes into 2. minus 5 is equals to 0. Right? So what is V? V is equals to Vs plus 9. Vs plus 9. So this is the actual voltage of this. V is equals to Vs plus 9. Because it is positive, it is a negative. Okay. V is equals to, let us suppose if it is Vs plus 9. But you don't know the voltage of the current source. You don't know the voltage of this current source. But mostly what the people will say that is, see, the voltage across the current source, write 0. But that is a wrong practice. Okay. So the Vs is not known. Okay. Vs is not known. Right. What is the Vs? The voltage across the current source is not known until he specifies. Okay. So write down the voltage across the current source. The current source is not known, is unknown until specified. Cannot be determined. The voltage across the source cannot be determined. See, observe this. Can we determine? Are you able to determine this? No. So you cannot able to determine the voltage across this current source. So that's why, see, what will be the option? The option, it cannot be determined, right? It cannot be determined. So that's why the none of this is the answer. Okay. The option is none of this. It's a very good thing. See, observe this. It is a Vs. So many people write this Vs as 0. So don't write Vs as 0 until it specifies. Okay. So it will be having an ideal voltage source will be having a certain amount of voltage. The ideal current source will be having certain amount of voltage. Okay. Write down the ideal and independent current source consisting a non-zero voltage. This is the thing you have to identify. Okay. So that's why you cannot make this one as 0 and you can write we cannot write V is as 9. Okay. So that's why this is the answer. So what will be the answer? It is a none of the above is the answer. Okay. Mostly what they will write, it will be equated to 0. That is a wrong. So why it is wrong? The ideal, this will be having some non-zero voltage. This current source will be having some non-zero voltage. Okay. Similarly, I will tell you one point. Suppose if in this question, observe this. Now find the current in the given circuit. Find the current in the given network. So how can you find the current in the given network? How can you find the current in the given network? See, you have to identify that. So you cannot determine the voltage across the, you cannot say how much amount drop will be there across the independent current source. You cannot determine the voltage across the independent current source. Now find the current I. The value of I is equals to how much? It is 2 amperes, right? 2 amperes is coming. Now what is the current in this? This I is equals to the current in this branch and current in this branch. We don't know this current. We don't know this current, right? Right or not? So that's why what we can write. So because we are not able to decide the current across this, current through this 1 volt source, okay, we are unable to find the current, the total current, okay. So cannot be determined is the answer. I cannot be determined is the answer, because we don't know how much amount of current it will be giving, okay. So that's why the independent voltage source consisting a non-zero current. So these are the 3 points you have to identify, okay. So we don't know how much amount of current will be supplied by this voltage source in this, so that's why you don't make it 0, okay. So definitely it will give you some amount of current, and this current plus this current will be is equals to this, because it is not given, because the current in this voltage source is not given, so you cannot determine the total current I, okay. So these kind of problems must be remembered, okay. It cannot be determined until it is given. So this is the next question. It's a very good question. It is asked in GATE 2012. It is asked in GATE 2012. So if you observe this question, what he asked, VA minus VB is given. That means he has given the voltage drop across this 2 ohm resistor is given, right? He asked us to find VC minus VD. The voltage difference between these two must be found. So this is the network given. If you observe this network, what he has given? VA minus VB is given. See, you try for yourself by pausing the video and take a pen and paper and try to solve for this, okay. So what are the techniques you learned, okay. So you can solve for the answer. So options are given. So observe this. So now I will start the solution. See, what is given? VA minus VB. How much has given? 6 volts is given. That means the voltage between these two is 6 volts, okay. It is plus, it is minus, it is 6 volts. VA minus VB is 6 volts, right? Now what will be the current in this? What will be the current in this? The current in this branch is how much? 6 divided by 2, it is 3 amperes. So the 3 amperes current is coming like this and coming like this. The 3 amperes is coming like this. Now if you observe this thing, see, if you consider this thing, entire thing as one network, let us suppose this entire thing as 1 and 2, okay, one network and 2, network 2. Suppose if you consider this entire thing as a network N1, okay. So how can I write? Suppose if there are 2 networks are there, 2 networks are connected like this, one is like this, the entering current must be is equals to leaving current, okay. The entering current N2. Suppose if it is I, it is also I. The leaving current for any network, for this network or this network, for this network or this network, and this is the leaving current, this is the entering current, and for this network, this is the entering current and this is the leaving current. Both are same, right? So the question is big, the answer is not that much if you have any kind of some basics, okay. So that's why whenever if the question is becoming large, if the question is looking very large, so there will be some point will be there, so which we can easily identify the clue for the solution. Okay, so that's why you don't get scared by observing the figure itself. Okay, just of all take a look, just 1 minute, maximum 1 minute. So definitely you will get some clue. Okay, definitely you will get some clue. Now if you understand this, see, this is one network, this is one network, in between we know the current. Okay, in between we know the current. So this is the current entering. This is the current entering this network, this entire network. Okay, if I name this entire network as N2, okay, the current entering this network is 3 amperes. Now the same amount of current will leave the network. What is this network? So this is the network, right? So the same amount after this D. So here the same amount of current should leave this. The current 3 amperes current is entering and 3 ampere current is leaving. The 3 ampere current is leaving here. So this 3 ampere current is leaving. Observe this. Here how much current is, how much amount of current is coming here? It is 2 amperes of current is coming here. If it is 2 ampere and it is 3 ampere, these 2 will add and here it will become, it is 5 ampere current. Right or not? Over, it is 5 ampere current. So 5 ampere current and here it will be plus, here it will be minus. Right or not? It will be minus. Now this is the 5 amperes current is coming. So 5 into 1, it is 5 into 1, it is 5 volts. So 5 volts drop across this. Now what we have to find? We have to find the VC minus VD. The VC minus VD is what? Means what? VC minus VD is minus 5 volts. VC minus VD is minus 5 volts. It is 30 seconds problem. 30 seconds. Within 30 seconds you can answer this. So whenever you know this concept, so you have to understand if the circuit is big means, so there will be some clue will be there. So the circuit is big means definitely the clues will be more. Okay, definitely the clues will be more. So that's the thing you have to understand. Okay. So this is a very, very good question. So here is a question. This is our next question. So in this network, find the magnitude of the current in the resistor R2. So how can you find the magnitude of the current in the resistor R2? Where the R2? R2 is here. So here you have to find the current in this branch. Okay. So how can you find? See. So we might have seen number of networks. Okay. But you didn't observe the resistor under this network. So whenever the resistor is placed under the network, okay, inside the bottom line of the network, the students may get demotivated to solve this kind of questions. Okay, so whenever you find the resistor in the bottom line of the network, you have to think once. Okay, so you cannot directly put the reference point somewhere. Okay, you can put, but it will not give you an exact answer. Okay, so for this what we will do, if you observe this, what we have to find actually, so whenever you are finding this kind of questions, you have to think once. Okay, whether the circuit may be simplified in any manner or not. Okay, directly you cannot solve by keeping the resistor like this. Okay, so just for a while you have to think whether any modifications can be done in the circuit or not. Okay, so whenever there is a resistor in the bottom line of the line, so definitely you have to think once whether there can be any kind of modifications can be done in the network or not. See, what we have to find? We have to find the current in this. We have to find the current in this branch, right? So how can we find? See, if you observe this is one current source in parallel with the resistance. This is one current source in parallel with a resistance. Okay, current source in parallel with a resistance, right? So now I am doing a small modification here. Now I am converting into source transformation. So we will use the source transformation. So how can we write the source transformation? Suppose if any current source is given like this in parallel with a resistance R, okay, let us suppose this IS, okay, RS, this can be converted as what? One voltage source in series with a resistance. So this is the thing. What is this voltage source? Vs is equals to Is into Rs. The multiplication of these two in series with the resistance. In series with resistance means what? Rs only. The same resistance is kept like this. Okay, the same resistance is kept like this. Suppose if it is given like this, suppose if the voltage source in series with the resistance is given, now you can convert into the current source in parallel with the resistance. So this is called as source transformation technique. This is called as the source transformation technique. Okay, this can be applicable if and only if the load parameters are to be calculated. Okay, if the source power or source, observe this, if the source power or source current to be calculated, okay, you cannot apply this. You cannot apply this. Okay, the source transformation technique. The source transformation technique is used only when the load parameters are to be calculated. So this is the point you should understand. Okay, so whenever if you want to find the source power or source voltage, so this source transformation technique cannot be calculated. So wherever, suppose if you want to find the load parameters, so you can find the in the left side at the source end, you can apply the source transformation technique. Okay, so if you observe this, if this entire thing is as what? One current source in parallel with the resistance. This is one current source parallel with the resistance. For a while I can assume this entire thing is one source and it is a load. Now I am assuming this entire thing is a one source and it is a load. Right or not? So now what I have to do? So it is just like that. I am not interested to calculate the current or power or voltage in this, but I want to calculate the current outside this. I want to calculate the current outside this. Observe this. I want to calculate current outside this. So that's why I can use the source transformation technique. Right? So that's why, see, observe this. So now I can use this as a source transformation technique. So a current source in parallel with a resistance can be converted into a voltage source in series with a resistance. So what is the voltage source? This one into this. It is 10 into 2. It is 20 millikilo. Get cancelled. It is 20 volts. In series with the resistance. What is the resistance? It is 2K only. 2 kilo ohm only. Now, so I can represent this entire thing as this one. Now 1 ohm source is there. So you can write 1 kilo ohm source. Now what is this? One current source in parallel with one resistance. So I can convert this into, observe this, I can convert this into observe what I am writing. Observe what I am writing. Right or not? See, so I have converted this entire thing into this one. Okay. So below this there is a R4 resistor. R4 resistor there is there. It is 3 kilo ohm. See where to put the plus and minus. See the plus is there here, right? The current is in this direction. So you can put the plus here and minus here. Okay. So at this place you have to put 2K. You can put here or here in series with. The resistance must be in series. You can also put here or here also. No problem. 1 kilo ohm resistor, it is as it is given in the question. Now what about this? This can be converted into the source. Which source? Voltage source. What are the polarities? The polarities are, here is positive, so that's why I am writing the positive terminal here. It is like this. Now it must be converted into one voltage source in series with a resistance. One voltage source in series with a resistance. What is the resistance? It is 4 kilo ohm. It is a 4 kilo ohm. So this is the thing. Some people will write this 4K here also. If you put resistor here or here, no problem. Okay, it will not affect the result. So now what we have to find? I have to find the 1K resistor, a current through the 1K resistor. I have to find the current through R2. R2 is how much? 1K resistor. See, I didn't disturb this one. I should not disturb this branch in which I have to find the response. Okay. So don't disturb that branch in which you have to find the response. So that's why I have kept the R2 in the same manner. Okay. So now what will be the current? So what will be the current voltage source here? 4 into 2. It is 8 volts. Okay. It is 8 volts. Now let us suppose the current is I, right? So if the current is going like this means it is 20. If I write KVL in this, if I write KVL, what is the current? I. The current is touching first negative terminal. So that's why it is 20 minus 2K into I. 2K into I, 2I. Minus 1K into I. Minus means it is plus 8 volts. It is plus 8 volts. It is minus 4K into I. Right? It is minus 3K into I. It is 0. Now from this, so what is the I? It is 28. It is 28. It is 28 is equals to minus 2, minus 3. It is minus 3, minus 7, minus 10I. It is 10I. So from this I is equals to how much? It is I is equals to 2.8. 2.8, but what is this? These all are kilos. These all are kilos, right? So you can write the kilo. So it is 10K, right? It is 10K. It is 2K. It is 1K. It is 4K. It is 3K. So you have to concentrate on the units also. Okay. So if I write this K here divided by K, okay, 10K. If I write this 10K here, it will be milliamperes. Okay. The current in this branch is milliamperes. Right? So can we use the nodal analysis here? Using the nodal analysis is a bit difficult. If the resistance is not there, you can directly write nodal analysis by taking V2 and V1 here. Okay, you can directly take the nodal analysis. But whenever there is a resistance in the bottom line, and it will be difficult to write the nodal analysis. With what respect, with what reference you can take them? This one. Either if see, observe this. If you find this, if you take this one as a ground, okay, so you can write the nodal analysis here, no problem. V2, this is what? Plus 2I, V2 minus V1 divided by this one. But with what respect? You cannot take here also ground. Okay, you cannot take here also ground. You cannot take two grounds in a single circuit because there is a resistance in between. If there is no resistance, you can take the two grounds, no problem. If there is any resistance is in between, you cannot take this. Okay, so that's why can't you use the nodal analysis means if there is any resistance, so you have to assume V1 and V2. So V1 and V2 can be assumed with respect to the ground only. Right? V1 and V2 can be assumed with respect to the ground only. So that's why you have to think once. So whenever there is a resistor in the bottom line of the network, so you should not, better to not go with the nodal analysis or KCL. So you think for something else. Okay? So definitely you will get the answer. Okay? So this is our next question. It's a very good question. Observe this. See, in the figure shown, find the value of I. Where the I, here is the I is given. So we have to find this current I. Find the value of I. So in this question, see how many loops are present? there are 4 loops are present in this. Okay, 4 loops are present. So you can go for the mesh analysis. Okay, how many nodes are presenting? How many nodes are presenting? 1, 2, 3, 4. Right? 4 nodes are presenting. Okay, 1, 2, 3, 4. Actually speaking, there are number of nodes, and you will come to know. See, this is one node, second node, third node, fourth node, fifth node. These many number of nodes are there. And but if you say it clearly, these all are short circuited if you observe this. So that means these all are representing a single node. You can also assume the same potential at all these nodes. Right? So you can use a mesh analysis or a nodal analysis, and also the number of sources are acting, right? So you can also use the superposition theorem. You can also use the Thevenin theorem also. How can you find the Thevenin's theorem? So you have to remove this branch. You have to find RTH. Okay, you have to find RTH and VTH. Okay, open circuit voltage you have to find, and the resistance also, equivalent resistance from looking into this. You can find the RTH also. So which one is simple? You have to identify. So which one will be simple if you observe this? Sometimes nodal analysis looks simple, sometimes the Thevenin equivalent will be simple, and sometimes superposition principle will be simple, and sometimes mesh analysis will be simple. Okay, so we have to go for the simplest way. So if you observe this, here is a node. Okay, let us suppose if I want to find this current in this branch. The current in this branch I have to find. Okay, in this branch I have to find the current. Now I am assuming, first of all, I am marking a ground. Okay, it is a very good practice to mark the ground. So wherever there is a reference is there, you have to identify proper reference. Okay, you can mark anywhere as the reference, but anyhow we will identify the reference in the bottom of the circuit. Okay, so what is the, you will come to know what will be the use of this assuming this reference. Okay, so this is a ground, so it is a 0 volts, right? If it is 0 volts, what about this? It is also 0 volts. If it is 0 volts, it is also 0 volts, right or not? So these all nodes are shorted, right? So now we have to find the current in this. Okay, there is a wire from here to here. Now I want to apply the KCL here. First of all, I want to apply the KCL. So let us suppose this is one node. I am assuming the node voltage V. What is the another node? Here is one more another node. I am assuming this one as V1. And remaining all nodes are this one only. This is one node, this is one node, this is one node. All nodes are equal to 0. Okay, all node voltages are equal to 0. Because I am assuming here 0 volts. Right? So if I apply then KCL at V. Suppose if you apply the KCL at V, what happens? KCL at node V, then what happens? V minus 8 divided by 1 plus means this current, this current, this current and this current. 4 currents I have to write. I am assuming all currents are outgoing. So V minus 8 by 1 plus V minus 0 by 1 means V by 1 plus V minus 0 by 1 means V by 1 plus V minus V1 by 1. V minus V1 by 1 is equals to 0. V minus V1 by 1. Right? So from this, if we simplify this, V, it is 4V minus V1 is equals to 8. It is one equation. Okay, 4V minus V1 is equals to 8. Now, is there any other equation? Yeah, there is one more equation is there. What is V1? V1 minus 0 is equals to how much? V1 minus 0 is equals to 8 volts. So from this, V1 is equals to 8. If you put this value here, so this is equation number 2. So 4V is equals to 4V minus, the 4 volts means it is 4 minus 8. Sorry, it is 4V. It is 4V minus V1 is how much? 8 is equals to 8. Okay, 4V is equals to 16. So 4V is equals to 16. This implies V is equals to 4 volts. V is equals to 4 volts. So that means here V is equals to how much? We got 4 volts. Right? So if the V is known, so we can easily find it. If V is known, now what about this current? So what is this current? We have to find this current, right? Right? So now come to this. This is how much? 1 ampere is coming. It is 1 ampere. Now what is this current? This current will be 4 minus 0 by 1. It is 4 amperes. 1 ampere, 4 ampere. It is 5 ampere current. The 5 ampere current is coming in this way. Now what is this current? This current is V minus 8 by 1. What is this current? This current is V minus 8 divided by 1. This is current, right? V minus 8 divided by 1. What is V? V is 4 minus 8 divided by 1 means what? How much it is? Minus 4 amperes. Minus 4 amperes means what? 4 amperes in this direction. Minus 4 amperes, or you can also write this one as what? You can also write 4 amperes in this direction. Minus 4 amperes are going in this way, or you can write in this way 4 amperes. So out of 5 amperes, 4 amperes are going in this way means, what about this current? This current will be minus, this current will be how much? 5 minus 4, it will be 1 ampere current. Because out of 5 amperes, 4 ampere is going means 1 ampere in this direction. So what is I? I is equals to minus 1 ampere. Because I is in this direction, but 1 ampere is going in this direction. So I is equals to minus 1 ampere. Right? So this way, so where to assume the node is very important. Okay? So it comes by practice. So it is a very good question. Okay? So most of the people will use the superposition principle. Most of the people will use Thevenin equivalent circuit, and some people will use the nodal analysis, mesh analysis. Okay. So first of all, you should, for any question, first of all you should go for the nodal analysis. If the nodal analysis is looking simpler, and follow that, no need to go for the other methods. Okay. You can also simplify by using the superposition principle. Suppose if you use the superposition principle, let us suppose this is acting alone. If the 5 ampere source is acting alone, then this all will be short circuit. This will be short circuit, this will be short circuited. Right? Let us try with the superposition principle. Okay? So the answer is how much? The answer is minus 1 ampere.